Hi everyone. So here we'll be starting with yet another question on binary search, Coco eating bananas. Okay, so this is type 2 question, I'll remind. And it will be a bit trickier, so be with me. And I hope you're coming from part 1 and part 2 videos of my binary search, especially that part 2 video. Now let's see what this question asks. So here, uh, Coco, like you were given a piles, Coco is given this pile, like, and it is containing uh, various piles of bananas. Like the first pile is having 3, then it is the next pile is having 6, then 7 and 11. So Coco has to, like, Coco wants to eat all this. And what the thing is, there are security guards who are like securing this lot, this piles. And you are given that for 8 hours, they'll not be available. So Coco is free for 8 hours. He has to like eat everything in 8 hours. Now you have to say, like, you have to give the minimum speed with which Coco, if Coco decides to eat, all these piles, he will be able to finish this pile in 8 hours. In at max 8 hours he'll need, that's it. Okay, so you want to give me the smallest possible speed, minimum number of bananas per hour. If he starts eating that, then he can eat that in less than equals to 8 hours, so that when security guards come, he should not be caught. So what I say, see, this first thing before when starting, and this is a constant that this h will be greater than equals to length. Okay, so I just wanted to share this. It is written in constraints. Anyways, so if let's say Coco starts with going eating 2 bananas per hour. Okay, 2 bananas per hour. So the condition, this is the condition. So uh, if Coco, let's say, here you see, for 3, if a pile has 3 bananas and Coco's speed is 2. Okay, so Coco can finish this in 1.5 hours. So in first hour, Coco can finish 2 bananas. Then in 0.5 hours, which is 30 minutes, Coco can eat one more banana. So this 3 bananas are done in 1.5 hours. But the thing is, Coco cannot, like, once he starts eating this one banana, this thing, and he consumed, like, he wasted some time here. Now the remaining time he cannot allot to some another pile. What I mean by this, he cannot allot, like, even if he cannot move to some other pile. So which means that for this to eat this 3 banana, if he is going for 2 banana per hour speed, he will take 2 hours. Okay, 2 hours. For this 6, he will take 3 hours. For the 7, guys, listen, for the 7, so 10 divided by 2, which is 3. 3 hours. 3 hours for sure he'll take. 3 hours. Sorry. No, correct. 3 hours for sure he'll take. In that 3 hours, he'll be eating 6 bananas. Now there is one more banana. There is one banana remaining. Divided by 2. It's not exactly 3. It's something 3 point. So he'll be remaining with some more banana, which is one more banana. So for that he'll waste his one more hour. He'll waste his one more hour. Okay. No matter how much time he's remaining with, he cannot go to another pile. Okay, in that particular hour. So he'll be taking 4 hours here. For 11, how much he'll be taking? 11 by 2, what is it? 11 by 2 is 5. 1 is there is some remainder in it. So 1 hour he'll take more. The entire hour he'll take more to finish this. He cannot move to any other pile, like whether he's remaining with time or not. So he cannot go to another pile, if even if is having some time remaining. So he'll take what? He'll take, and how much? 6 hours here. And see, guys, how I'm deciding how much will I take. This is the thing that I do, like, whenever I try to go over my test cases. I try to generalize how would I solve this when I'm going to write this in code. So how would I decide? I'll just, like, how much our Coco will eat, Coco will take for particular pile. So if he's having b bananas per hour, so as I said, let's say you are going at this particular ith. So a of I, or p piles of I, divide by what? B number of hours. So here you will be giving this h hours, let's say. And the second thing is, you have to see whether it has some remainder or not. So 11 by 2, you get 5, but again you are having some remainder as well when you do this modulo operator. There's a better way to do this. You can comment me down. There's a better way, but it is the simplest that you can think, as I said. So there is some remainder, no matter what, but there is some remainder. So Coco will take one more hour. So if it has some remainder, and which means the remainder is greater than 0, you will add +1 to here as well. 5 + 1, 6 hours. Okay, so this thing is clear. Now let's see. So if Coco decides to, like in this way, you got this, that Coco would have to consume the entire pile in that hour. He cannot use his speed in some other pile. So in brute force, what you can do, guys? In brute force, what you can do? See this. Let's say you take a number line 1, 2, 3, 4, 5. Forget about the upper limit. Just be with me here. So let's see this. This is the number of bananas he will eat per hour. So he decides to go with one banana per hour. One banana per hour. He cannot finish that in 8 hours. So you go with into right. Two bananas. 2 plus 3 plus 4 plus 6. This is obviously greater than equals to 8. Not with 2, not with 3, with 4 he will. And as soon as, what I say, as soon as you see with some particular pile, as soon as you see that particular speed you get, with which if he eats, let's say that is b, minimum speed b, with which if he eats, he will finish this entire thing in less than equals to h hours, which is 8. Then you will not move to right, then you will not go to right. Why? Because obviously if Coco can finish this everything in 4 hours, because, and you want the minimum speed first. See this, if Coco can finish this in 4 hours, you should not go in right. Why? Because if Coco can finish everything in with going with a speed of 4 bananas per hour, if he can finish it in 8 hours, if he increases his eating speed 5, obviously he'll be finishing it everything in lesser time than this. So you don't have to go to right, just finish, just end your loop here. So you see, guys, here you get the hint of binary search. Why? Because in brute force you're going with order of n time plus the array space was shorted, and once it is binary search, you decide this binary search, we have to see how we divide this space in like various parts. Okay, so be with me, I'll help you in this. So what you were given initially, this lot 3 6 7 11, 3 6 7 11. Okay, 3 6 7 11. And what I said in linear search, let's say we draw a number line 1 2 3. Forget about upper limit, higher limit, we'll come to that. But and L will be here, of course L will be here. Now you see, initially Coco was not able to eat, because initially with this much of speed Coco was not able to eat the entire pile, the entire lot in h hours, in 8 hours. Let's see this number, 8 hours. So what do you think? This is your unfavorable range. This is your unfavorable range. Listen, this is your unfavorable range. Why? Because up to this 3, Coco was not able to eat in 8 hours. He requires more than 8 hours. And once from you get this 4, now from 4 onwards, because for 4 you know that Coco can eat. This was the answer, obviously. Even if you go with this, let's see this. It has 3 piles, so Coco will need only 1 hour. It has 6 piles, Coco will need 2 hours. Why? Because 6 divided by 2, 6 divided by 2, sorry, 6 divided by 4, it is 1. But 6 modulo 2, it has some remainder as well, so he'll need 1 more hour. So 7, for 7 Coco will need 2 hours. For 11 Coco will need yet how many hours? 3 hours. So if you see, 3 plus 1 4 plus 2 plus 2, which is 8. So Coco can finish everything in 8 hours if he goes for with 4 speed. Now if he increases his speed, obviously he can finish it in less than 8 hours, because he has increased his eating capacity, so time taken will be reduced. That is normal mathematics, guys. So starting he will be having unfavorable, then later on he will be start getting favorable. All this speed, with all these speeds, Coco will finish the bananas. But what you want, guys, what you want? The minimum speed you want. Okay, the minimum speed. Now see, guys, see this very carefully. So if your L and H start here, what you want? The first value, the first index of last space. And who gives you that? When binary search is about to end, I hope you know you're coming from part 2 video, you know that L will be here, H will be here. So who will give your answer? L will give you answer. That is it. L will give you answer. So this binary search template, I'll show you in next slide. The binary search template will remain as it is. But this time, guys, see this. Who will, because this unfavorable and favorable, you only think of it. You don't do something like you don't create array. It is automatically divided into 2 regions depending on your conditions, your if, whatever you remember in that inside while we write this if. Okay, then we decide L equals to something, H equals to something. Okay, if and else. So this thing, and as I said, this is type 2 problem. So to decide some particular zone is unfavorable, some particular zone is favorable, you have to write some function. Let's call this function as can eat. It will take Coco's speed, like let's say b, initially, like with what speed Coco will be eating, because obviously in binary search what we do, we calculate mid between L and H. I'll not come right now, let me come later. You will go, this mid is what the speed of Coco is eating, and then you will give H the maximum time Coco has, and you will giving him piles, all the piles. Now this can eat function will tell that with this speed can Coco eat or not. Let's say you write that function, here you put that function, and if that function returns true, which means that Coco can eat, so which means that you are in favorable zone. And guys, if you are in favorable zone, let's say your mid was here, this was your speed that you gave to Coco, that Coco start eating with this speed and let me know whether you can finish it or not. Coco said, yeah, I can finish it. So do you think you should go to right or left? Obviously you want the minimum speed, you want the first favorable, so where you have to go. And this is why, guys, I say that in binary search, this is the beauty, that once you decide your search space into this unfavorable favorable, forget about this, just see this, because if you see these numbers you can get confused, but you see this only two values, unfavorable, favorable, there will be no confusion. So if Coco is at this favorable, you will do what? You will do H is equals to mid minus 1, you will go to left of it. So H is equals to mid minus 1, guys. H is equals to mid minus 1. Why? And when Coco says that I can eat, if this function is here. Otherwise what happens, let's say you are at unfavorable, if Coco says no, I cannot eat, man, I'm at unfavorable zone, I cannot eat. What you will do? You cannot go to left right now, because this is of no, because if Coco is not able to eat in 3 hours, can he? If he is not able to eat with 3 banana per hour, if you do it in 2 bananas per hour, obviously he will not able to eat, because this is greater anyway. So Coco will go to right in this way. Coco will go to right. So L is equals to mid plus 1, guys. L is equals to mid plus 1. That's it. So this is what the template will be. And if I show you this, and our main task is to write can eat function. Okay, now let's see how will we write this can eat. Okay, can eat function, how will we write? As I said you, at every point you will be given what, these these three values. Now let me just show you this, otherwise it may take some time, and directly I'll go. So let's say you were given the piles. What was that? 3, 6, 7, 11. 3, 6, 7 and 11. Now how will you write this function? Let's say you start iterating for and create a value sum, create a variable, let's say sum or count, whatever you want, no problem at all. Okay, this will check how many hours Coco has spent till now. You'll start from I equals to 0 to and we are writing can eat function. Remember, guys, I is less than piles dot size, to the size of piles maximum. We will go not more than that. Now you have to see for every pile how much our Coco takes. Okay, see this. So what you have to do, let's say you calculate int h, number of hours, the smaller h, number of hours Coco will take to finish ith pile. Okay, so as I said, divided, and you have this b is the Coco's speed right now, number of bananas per hour. So what you have to do, p of I divided by this b. Okay, p of I divided by this p. So let's say if Coco decides to go with 2 speed, so 3 divided by 2 is what, 1. So this is 1, h is 1. But you see 3 divided by 2, you are having some remainder, so what Coco has to do, Coco will waste one more hour eating that remainder as well, that remaining bananas. Okay, so you have to see if your remainder, your piles, number of piles at ith modulus, this is modular operator, it will help you to get the remainder. If it is not equals to 0, which means Coco, and after consuming this, divide this lot, 3 divided by 2, which means he consumed 2 bananas, he's remaining with some, and he has to spend 1 more hour for that. So you will do what, h plus plus. So for ith pile he will take h hours, and in this way he'll go. And finally what you will do, you are, let's say, tackling this number of hours Coco in count, Coco spent it till this pile, and it is count. So what you will do, count plus equals to h. Okay, so this h is for individual piles, this count is for the entire lot. And finally you see, if Coco, this is the count, if Coco is taking greater time than what you gave him, then you'll return what? False. You'll return 0, otherwise you'll return 1. I hope this sort of thing is clear. How am I writing can eat function? As I like described earlier in my slide 1, that how we have to decide that, let's say you Coco is going with the speed 4 bananas per hour, and he has to consume 11 bananas. How much time will he take? By seeing, you can say that 11 divided by 4 is 3. So 3 hours he'll take, sorry, 2 hours he'll take to, and he'll finish 8 bananas, but he's remaining with 3 more bananas. And how will you get that? 11 modulo 4. So he is remaining with some more bananas, and for that he'll take 1 more hour. So 2 plus 1. So this is what I've written here, guys. Don't get confused in this. This is what I've written. So this is it. Now you decided a can eat function. If you see while L is less than equals to h, we calculate the mid. This is your the function that will tell you whether you are in favorable or unfavorable. You know, this is your favorable zone, this is your unfavorable. You will return what? You'll return h. Wait, you'll return L. You wanted the first index of last space, so you will return L, because at the termination while loop was ending, L will give your answer. You'll give L. Now just think, as I said, L, it can be 1. Now what about h, the higher limit? So higher limit, guys, it will be the maximum. It will be, let's say, the maximum banana, because the lower limit can be 1. Coco can start eating with 1 banana per hour. But what is the h? For binary search, we need h. So h will be the maximum banana that it can get here. So let's say if Coco decides to eat 11, at max he can eat, if he decides to eat 11 bananas per hour, Coco will finish everything in time. Coco will finish everything in time. Okay, why? Because 11 is the maximum. 11 is the maximum banana in a pile, and if Coco decides to eat 11 bananas per hour, so he will finish this in 1 hour, he'll finish this in 1 hour, he'll finish this in 1 hour, he'll finish this in 1 hour. So he'll take at max of 4 hours. He'll take at max of 4 hours. So more than 11 you don't want. Like at max, Coco will finish everything in 11 hour. Sorry, in 11 with 11 banana per hour, Coco will finish everything. This is you are sure. And why you are sure this? When I wrote this constraint, that the h, the number of hours will be greater than equal to the length of this pile. So if you're given 8 hours, let's say, so here you see the length of it. Okay, it gives you the hint for h. So your upper limit will be the maximum banana in a pile in that particular array. Okay, I hope you got everything. So now let's see what my solution is. So here the first thing, wait, let me change my pen. So this particular loop, it gets you what? It gets you the max. It decides you the h. What does it mean? The maximum number of bananas in a pile. Okay, so here in the previous one you'll get 11. So then you start your while. So your binary search, you see, other than this, if you avoid this can eat, the binary search is very clean, it is neat. Whatever like we think on a basic template, it is that only. Now it is only that when you can eat, the Coco said that I can eat, it is your favorable zone, and if you are in favorable zone, you cannot go to right, you have to go to left, because you have to find the minimum one. So depending on this, you'll return L. And how I wrote this can eat, you can get that directly. That let's say there I used one more variable, but here I'm avoiding that. What I'm doing is directly sum plus equals to p of I divided by mid, and if you are remaining with some more modulo, some more remainder you are remaining with, you will again increase sum plus plus. And this is the shorthand condition. Just see this, guys, it is not confusing. See this, if your sum is greater than h, let's say what Coco wants, the number of Coco wants, if it is greater than h, you'll return not, which means you'll return 0. So this sum is greater than h, it will give, let's say Coco wants 9 hour. So if Coco wants 9 hour, but you are giving him 8 hour, so 9 is greater than 8, it will give you 1, this boolean thing. But you don't want to return 1, you know that in this condition you have to return 0. So no, add a not here. So obviously you can go here as well, write this long thing, if count is greater than h, return 0, else return 1. But a shorthand of it, try to use shorthand. In real world, in development, you use this a lot. So that's it, guys. I hope you liked it. Do let me know in comments you like my intuition or not, and we'll meet in another video. Thank you.